So today we're hitting conics and we are hitting parabolas. So a conic section is a curve that is formed by the intersection of a plane and a cone. So in the upper right, you can see the cone and the plane. This plane is going to hit the bottom of the cone or the top of the cone, creating a parabola. A parabola is going to be formed by connecting all points equidistant from a point called the focus. So that parabola is going to wrap around the focus and a line called the directrix. Now, the vertex is a point that lies on the axis of symmetry. So here's the axis of symmetry. The vertex is on that line, and it's exactly halfway between the focus and the directrix. So we're going to call the distance between the vertex and the focus, or the distance between the vertex and the directrix, we're going to refer to that as P. Now, P is going to be a directed distance, which means that if P is positive, then that parabola is going to open up. And if P is negative, then that parabola in this first one is going to open down. You can see the general form of the equation. X minus h squared equals 4p times y subtract k. HK is going to be the vertex of the parabola. Notice that we have either the x is going to be squared or the y, but not both. All right, so let's look at this other parabola that's going to open left or right. If it opens up or down, the x is squared. If it opens left or right, the y is going to be squared. So you can see the general equation is y subtract k. I always remember that h's always go with x's and k's always go with y's. So h's with x's, k's with y's. So y minus k squared equals 4 times p times x subtract h. Now, here's the vertex again. And the vertex is going to be on the axis of symmetry. That's the line, the imaginary line that cuts that parabola exactly in half. The distance from the vertex to the focus is P, and the distance from the vertex to the directrix is also going to be P. The directrix is always going to be perpendicular to the vertex. Now you can see here that if P is greater than 0, so positive, then this parabola is going to open to the right because the parabola is always going to wrap around the focus. If P is negative, that parabola is going to open to the left. Some formal definitions that you can go over, and I just went over those when we were looking at the other slide, but we have focus, directrix, axis of symmetry, vertex, and then parabola is that bowl-shaped conic that we're going to be hitting today. Here are the 4 different equations one more time. If there is no h or k, that simply means that the vertex is going to be at 0, 0. So looking here, if you have x squared, the parabola is going to open up, or the parabola is going to open down. And this is a little bit blurry, so let me fix this. This should be equals right here. So this should be x squared equals 4py. Now, if the p is positive, then so see here, p is greater than 0, then the parabola is going to open up. And if p is negative, so here you can see it says p is less than 0, then the parabola is going to open down. Here again, you can see that I have the focus, and I'll put the focus in pink. So here's the focus, and the focus is always inside the bowl-shaped conic. And then the directrix is always perpendicular to the axis of symmetry. Again, the axis of symmetry is this green line that cuts the parabola down the middle. Okay, so then what about y squared? So here you can see x is squared and y is to the first power. So now we're going to look at where y is squared. So you can see y is squared on both of these, which is going to make this parabola open up to the right or open up to the left. Because there's no HK, the vertex is going to be at 0, 0. So the blue is the vertex. The directrix is what runs perpendicular to the axis of symmetry. The focus is what's inside the bowl-shaped conic. Now you can see when P is greater than 0, then that parabola is going to move to the right or open to the right. And when P is less than 0, the parabola is going to open up to the left. Sketch the graph of the parabola. X equals -1/3 y squared. The first thing we're going to do is just change the form. And so this y squared we're going to get by itself. So we're going to go ahead and get rid of the -1/3. And how we're going to do that is we're going to multiply both sides by -3. Therefore, the -1/3 and the -3 will cancel, and that's going to give you just y squared. So now I have right here y squared equals -3x. The first thing you want to do is determine, does this graph open up, down, left, or right? So because the y is squared and the x is not, this is a left or right parabola. Now, because this is negative, we know that this parabola is going to open up to the left. So let's figure out what the focus is and what the directrix is. So the first thing I want to do is figure out what P is. So the equation is y squared equals, and then it is 4px. So what we're going to do is we're going to take this -3, which is in front of the x, we're going to set it equal to 4p, and that's going to tell us what p is. So let's figure out what p is. So if 4p is equal to -3, then when I divide by 4, I know that p is equal to -3/4. Now, because there's no h or k, we know that the vertex of the parabola is at 0, 0. Now, because this parabola is opening to the left, and again, I know it's going to the left because of this negative, then I know that the focus is going to be to the left of the vertex. So I'm going to go to the left by 3/4. So right here is the focus. The directrix, and if I wanted to write that as an ordered pair, I would go left 3/4 and up 0. Now the directrix is going to be a perpendicular line to the axis of symmetry. The axis of symmetry is the x-axis. So I'm going to go to the right 3/4 and draw the directrix. So here's the directrix. It's that dotted line. The equation is x equals +3/4. And I can write it over here as well. So x equals +3/4. So that is that vertical line right there. Okay, so now we are ready to draw our parabola that opens up to the left. Here's something that's kind of cool, and it's called the focal width. And the focal width is going to be the width of the parabola through the focus. And so the width of that parabola is going to be the absolute value of 4p. And we found out what p was, it was -3/4. So if I take the absolute value of 4 times -3/4, then you can see that the 4's are going to cross cancel, and it's going to equal -3, and the absolute value of -3 is +3, and that is the focal width. So let me show you what that is. So what that is you would go to the focus, you would divide the focal width in half. So that means you're going to go up 1.5 and down 1.5, okay? And the focal width, this parabola is going to go through those 2 points like this. And the reason why it's called the focal width is because it is the width at the focus. So here's the focus, here's the width at the focus, and that width happens to be 3. So the total length of this line here is 3 units. And now I've just graphed my conic. So looking at example 2, we're going to find the equation of the parabola, and the vertex, or the HK, is going to be 0, 0 because it's at the origin. And they're going to give us a clue about the parabola. So this first one tells me that the focus is 3, 0. And sometimes it will help if you just draw yourself a little graph to help you with what that looks like. So right 3 and up 0 is the focus. Well, we know that the vertex is going to be at 0, 0. The parabola always wraps around the focus. So therefore, we know this parabola is going to open up to the right. So if you go to that first page of notes, you'll see that the equation for opening up to the right is a y² equation, where the y is squared and the x is not. And the equation is y equals 4px. Now what you're going to do is you just have to figure out what p is, and then you can write the equation. Well, that's pretty easy because p is the distance from the vertex to the focus, and that is always your p. And p happens to be what we call a directed distance, which means this is going to be a positive because we went to the right. And if we directed that to the left, then we would have p be negative. So therefore, p is +3. Plug p in, and you have the equation of the parabola. So y² equals 4, and then you have p, which is 3, and then you have x. So y² equals 12x. And there's your equation of the parabola. Okay, so looking at the next one, we have the focus is at 0, -3. So thinking of what this graph looks like, remember that the vertex is at 0, 0. The focus is 0, and then go down 3. 1, 2, 3. Because the parabola always wraps around the focus, we know that this parabola is going to open down. So this is going to be an x² equals 4py equation. Now, p is the distance from the vertex to the focus. So that is p. And we went 3 units, but it's directed, which means we went 3 units down. And so therefore, p is -3. Take -3, plug it in. For p, you get x² equals 4 times -3y. And so the equation is x² equals -12y. And that's the equation when the focus is 0, -3. Okay, so now they're going to give us a hint with using the directrix. Directrix is y equals -1. You know that -1 y equals is going to be a horizontal line that goes through -1, and that's your directrix. So therefore, the vertex is going to be at 0, 0, and the focus is going to have to be 1 unit up because the vertex is exactly in the middle of the directrix and the focus. So here's our parabola. You can see that that parabola is going up, which is an x squared equation. So x squared equals 4py. Again, now we have to figure out what p is. P is the distance from the vertex to the focus, and it's directed. So because it's going up, P is equal to a +1. Take 1, plug it in. So now you have x squared equals 4 times 1 times y. So x squared is equal to 4y. And there's your equation when the directrix is y equals -1 and the vertex is at 0, 0. Okay, last one, and that's when the directrix is at x equals -1. So x equals -1 means that you're going to have a vertical line that goes through -1. So here is your directrix at -1. The vertex is at 0, 0, and the, oh, sorry, don't know what happened there. Undo. Okay, and the focus is going to be at +1. So here's your vertex. And so this parabola is going to be opening up to the right. So this is going to go in this direction. And here is your focus. So we need to find the distance from the vertex to the focus. Well, if from the vertex to the directrix is 1 unit, then from the vertex to the focus, it's also 1 unit. The vertex is smack in the middle of the focus and the directrix. So P is 1. Because this is a parabola that opens up to the right, it's a y squared equation, which equals 4px. Take P, plug it in. So y squared equals 4, plug in the 1, and then you have x. So the equation is y squared equals 4x. All right, I'm hoping you're getting this. Let's go on to the next example. So looking at this one, it's a parabola that opens up. So we know it's an x squared equation. So x squared equals 4py. We know that the point on the parabola xy is 2, 3, and the vertex is at 0, 0. First thing we want to do is figure out what p is. So how we're going to do that is we're simply just going to plug in x and plug in y. So when I plug in x, that's a 2. So this will be 2 squared is equal to 4 times p times y, and y happens to be 3. So 2 squared is 4, which equals 12p. Divide by the 12, and you know now that p is 1/3. So if p is 1/3, you're ready to write the equation. So the equation is going to be x squared equals, oh, by the way, the vertex here, so you can see it was 0, 0. So x squared is 4 times 1/3 times y. So x squared is equal to 4/3 y, and there's your equation. You notice that the x is squared and the y is not squared. Therefore, this is a parabola that's going to open up or open down. Because the 8 is positive, we know that this parabola opens up. Now, x plus 7, remember h's always go with x's. So the formula is x subtract h squared, which equals 4p times y subtract k. So if this is x plus 7, this really is x subtract a negative 7. So the h is negative 7. And the k is going to be y subtract k. So the k is the positive 3. So there is your hk, negative 7, positive 3. That's going to be the vertex of your parabola, which is drawn right here. So we went left 7 and up 3. Now let's figure out what p is. For p, if you look at the two equations lined up, 4p is going to be equal to 8. So p then, if you have 4p equals 8, then you would divide by 4, and p is equal to 2. So the vertex we already did, it was hk, which is negative 7, 3. And then from that vertex, we're going to go up a positive 2. And because p is positive, we went up, and that's the focus. And then we're going to go down 2, and that's going to be the directrix. So there's the directrix. So the focus is at, now we are going to have to get to this point, notice we went left 7 first, and then from there we went up 3. So then from the vertex, we went up 2 more. So when the parabola opens up or down, the focus is going to be h, which is the left 7, comma, and then you're going to have k plus p. So there's your focus. So this focus is left 7, and then k was 3, and then we went up 2 more. So k plus p, which is negative 5, 7. The directrix is going to be y equals, because it's going to be a horizontal line, and it's going to be k subtract p. So again, k was 3, so 3 subtract 2 is 1. So the directrix is y equals positive 1. So example 5, it wants us to write an equation of a parabola whose vertex is at 3, 2. So that is your h and your k, and you can see it's graphed down here at right 1, 2, 3, and up 1, 2. So there is your vertex. It says that the focus is at right 4, up 2. So because the focus is wrapped around by the parabola, this parabola is going to open up to the right. So if we look at the equation for a parabola that opens up to the right, then this is going to be a y squared parabola. So it would be y subtract k, again, k's always go with y's, squared, equals 4p, and then the x subtract h will not be squared. Parabolas always only either the y or the x is squared, not both, or then you're looking at circles or parabolas, not parabolas, circles or hyperbolas, or ellipses. Okay, so we're going to begin by sketching the graph. And when you sketch the graph, you can see that this graph, it has to open to the right. That's your only choice, and that's why I selected that equation. Once you do that, it is really easy. All you have to do is figure out what P is, and then you can write the equation. Well, remember, P is the distance from the vertex to the focus. So the distance from the vertex to the focus is 1. And since the parabola opens right, that P is going to be positive 1. So we use this equation and we write down what HK is. And HK is 3, 2. And P is positive 1. And now we're ready to write the equation. So the equation is y subtract K. K is the 2. Be really careful with that. and it's going to be squared, and that equals 4, because 4 times 1 is 4. And then you have x subtract 3, and you're all done. So now let's look at a real-world problem with conics. The paraboloid of a revolution is going to be a parabola in three-dimensional space that rotates about its axis. So we're looking at flashlights, headlights, searchlights, satellite dishes, speakers. And so where that focus is in a flashlight where we're going to put the bulb, or in the satellite dish where we're going to put the receiving antenna, so that we get the most reflection through that point. So looking at example 6, you have a satellite dish which is 82 feet in diameter. So what that means simply is the entire width of that parabola is going to be 82 feet. So it says that there's a depth of 10.25. So there's a point on that parabola that you would go right, 41, because the entire width, we're going to put the vertex at 0, 0. So the entire width is 82, which means from the center, you would go to the right 41 and to the left 41, and that's a total of 82. And then here, if I went right 41, I would go up 10.25. So that's a point on the graph. From there, we want to figure out what the focus is. So we'll take the equation x squared equals 4py. There's no hk because I put the vertex at 0, 0, and then simply plug in x, which is 41, and plug in y, which is 10.25. When I take 4 times 10.25, I get 41. When I divide both sides by 41, I decided to use the property of exponents. So 41 squared divided by 41 to the first power is simply 41. Once you know what P is, you know what the focus is, and that's 41 feet from the vertex. So that's where you want your receiving antenna to go. So the you're going to try all on your own, and we'll also do it in class. All right, here is our very last example, and we're going to put our parabola in standard form. So first off, how do I know it's a parabola to begin with? Because the x is squared and the y is not squared. Because of that, I know it's a parabola. In standard form, when x is squared, the standard form equation would be x subtract h's always go with x's, equals 4p, and then you would have y subtract k. So that is the standard form of a parabola. In order to get it to look like that, we're going to do some completing the square, just like we did with circles. So you have x squared subtract 2x, and then you're going to do plus something when you complete the square. That's going to be our x subtract h quantity squared part. That is going to equal, take everything else and move it to the other side. But to move this to the other side, you would have to subtract 4y, and you would have to add 3 in order to undo to get it to the other side. So this is going to give me a negative 4y plus 3. Okay, so let's go ahead and complete the square first, and then we'll go from there. So to complete the square, here's complete the square. You take b, you divide it by 2, and you square it. What is b? B is the number in front of the x. So you take negative 2, you divide it by 2, and you get negative 1. You are going to square negative 1. You can put positive 1 there if you want, because negative 1 times negative 1 is positive 1. What you do to the left side of the equation, you do to the right side of the equation, so that everything is balanced. All right, now that it's all balanced, let's go ahead and factor our perfect square trinomial. That is going to factor as x subtract 1 quantity squared, which equals negative 4y plus 4. Now, this isn't quite in the right form yet because we want just y minus k. So in order to get y minus k, we're going to factor out the negative 4. So you factor out the negative 4, and that gives you y subtract 1. And then this one is x subtract 1 quantity squared. So the equation of the parabola is this. If you wanted to know what the parts were, the h and the k are going to be positive 1, positive 1. So the hk would be 1, 1. And then you could go through the p. If you wanted to figure out what p was, you know that negative 4 is equal to 4p. So the p is actually negative 1. And this would help me if I were going to graph it. Looking at it graphically, if hk is right 1, up 1, okay, that's your vertex. P is left 1 from the vertex. So here is the focus. And because it's moving to the left, this is going to open to the left. And the directrix is going to be behind it. And we know that the distance from the vertex to the directrix is 1. And the distance from the vertex to the focus is 1. But because this was a negative, we know that it opens left. That's what we mean by directed distance. And there's your parabola. Make sure that you do your reflection question, and then we'll work on ellipses next. Thanks, everybody. Have a great night.